All right, let's talk about something we use every single second of every day, but how many of us really get how it works? I'm talking about electricity. Today, we're going to break it all down to its most fundamental parts, the real building blocks. Let's jump in. Think about it. You do it a dozen times a day. You walk into a room, you flip a switch, and boom, light. It feels like magic, doesn't it? But it's not. Something absolutely incredible is happening inside those walls. An invisible river of power just woke up. So, what is that river? What's actually going on? That's what we're here to figure out. Okay, first things first. We have to start with the spark itself. Before we can get to the cool stuff like circuits and computers, we need to understand what electricity even is. When you boil it all down, it's actually kind of simple. It's just electrons moving. That's it. See, everything is made of atoms, and atoms have these tiny little particles called electrons. In materials like copper wire, those electrons are pretty free to jump from one atom to the next. So when you give them a little push and they all start moving in the same direction, well, that flow, that is electricity. So what is that push I just mentioned? Well, that's voltage. The best way to picture it is to think about water pressure in a pipe. The more pressure you have, the stronger the push on the water. Voltage is exactly like that, but for electrons, more voltage means a stronger push. Right, so if voltage is the push, then current is the actual flow. It's the measure of just how many electrons are zipping past a certain point at any given moment. Sticking with our water analogy, this is the volume of water flowing through the pipe. Is it a tiny trickle, or is it a raging river? That's current. And that brings us to the third piece of our puzzle, resistance. Just like the name implies, it resists the flow. It's anything that slows those electrons down. In our water pipe, this would be like a narrow section or a clog. And the main idea to remember is super simple. The higher the resistance, the lower the current. Okay, so we've got the push, the flow, and the thing that slows it all down. But none of that is useful if the electricity has nowhere to go. To actually do some work like power a light bulb, it needs a complete path to travel on, and we call that path a circuit. Turns out, every single working circuit has to follow these 4 rules. It's like a recipe. You need a power source, like a battery, that's your push. You need a path, which is usually wires. You need a load, that's just the thing that's doing the work, like a light bulb. And finally, and this is the most important one, you need a closed loop. The path has to be a complete, unbroken circle from start to finish. And here's exactly why that closed loop rule matters so much. On the left, you see a complete circle. The path is unbroken, the electrons are flowing, and look at that, the light is on. Now, on the right, there's a break in the path. The loop is open, the electrons hit a dead end and stop, so the light is off. This simple idea is literally how every light switch in your house works. All it's doing is opening and closing that loop. Now, a simple on-off loop is just the beginning. To build the incredible things we have today, from radios to smartphones, we need to do more than just turn things on and off. We need to precisely control the flow of electricity. And for that, we need to open up our toolbox of special components. So here are the stars of the show. You have your resistor, whose whole job is to slow the flow down. Then there's the capacitor. Think of it as a tiny, super fast charging battery. A diode, that's basically a one-way street for electricity. And then the transistor. This one is the real game changer. It's a tiny, microscopic switch that can be flipped on and off by another electrical signal. Billions of these working together are what allow a computer to actually compute. Okay, so that's the theory. Now let's see these things in action. This is where we see how adding these components completely changes what a circuit can do. Let's take that resistor. We know it slows down the current. So in the real world, what does that mean? Well, it's how you dim a light. More resistance means less current gets through, which means a dimmer light. Pretty straightforward. Or if you've ever turned the volume knob on an old stereo, chances are you were just adjusting a variable resistor. And what about the capacitor? Remember our tiny, ultra-fast battery? It can absorb extra voltage when there's a surge and then release it when there's a dip. It basically smooths out any jumpy electrical signals, making the power supply nice and stable. This ability to store and release energy is also the secret to how a radio tuner can lock on to one specific station. All right, let's zoom out. We've got our basic forces, we've got the rules of a circuit, and we've got our toolbox of components. So how in the world do these simple building blocks come together to create the complex gadgets we use every single day? Let's look at a radio. First, an antenna catches invisible radio waves and turns them into a tiny electrical signal. Then, a tuning circuit.
using our friend the capacitor, is adjusted to resonate with just one station's frequency, filtering out all the others. Finally, that one isolated signal gets amplified and sent to a speaker, which turns the electricity back into sound. Simple, right?
And this is the most important point of all. A smartphone might seem a million times more complex than a radio, but it's built from the exact same fundamental pieces: a power source, pathways, and components like resistors, capacitors, and transistors, all just controlling the flow of electrons.
I mean, just by understanding voltage, current, resistance, and a few of these key components, you now pretty much grasp the core principles behind about 90% of all the electronic devices you've ever used. The rest is just about combining these simple blocks in more and more creative ways.
So there you have it. From a single moving electron to the supercomputer in your pocket, everything follows the same fundamental rules. Now that you understand the foundation, the only question left is, what are you going to explore next?